Welcome to our first practice of our third type of JTB. Here we have a little rational function, and let's go ahead and get started. The algebra gets a little bit more challenging, particularly in the second derivative, so we're going to need some practice. We're also going to need some space, so I'm going to minimize some space here. So f prime of x, first derivative, equals low x squared plus 4 d high, derivative high, times negative 2. Minus high, which is negative 2x, so minus a negative plus 2x, d low, derivative of the low function is 2x, all on the square of the thing below, x squared plus 4 squared. Cleaning that up, I get numerator, negative 2x squared distribute, minus 8, terrible 8, plus 4x squared, all on x squared plus 4 squared, or 4x squared minus 2x squared, 2x squared minus 8 on x squared plus 4 squared. And I like that form. It has its place, but I'm also going to go ahead and factor that numerator. That becomes 2 times x squared minus 4. And that becomes 2 times x plus 2 times x minus 2 on x squared plus 4 squared. So I'm going to write that one down below. I like that form as well. You'll see why if you don't know already. Because the next step, I want to find out when this is 0. And when this is 0 is when either x is negative 2 or x is 2. X is 2, the slope of the function is 0. When x is negative 2, the slope of the function is 0. When x is in between those, say 0. I've got a positive times a positive. If x is 0, this would be negative. Positive, positive, negative, negative. If x is 10, something out to the right, this would be positive. This would be positive. If x is 10, this is positive. Positive, positive, positive. Negative 10. If x is negative 10, something out here to the left, positive. This would be negative. This would be negative. Positive times negative is positive. Not so bad. So the graph goes up, levels off, comes down. We've got a maximum at negative 2. The graph goes down here, levels off, comes up, negative slope, slope 0, positive slope, and we've got a minimum at 2. Furthermore, the graph is increasing where the slope is positive, negative infinity to negative 2 in union with 2 to infinity, and it is decreasing where the slope is negative from negative 2 to 2. Not so bad. Let's go second derivative now. For the second derivative, I said I'm going to come back to here. I just think it's a little bit cleaner. 2x squared minus 8 on x squared plus 4 squared. I'm trying to find the derivative of that to get our second derivative. All right, low. Well, not pretty, but not hard. Low is x squared plus 4 squared. Low d high, that's times the derivative of the high function, 4x, minus high, 2x squared minus 8. D low chain rule, treat the mama, 2 times something to the first. We don't need the 1, but that's just for emphasis. Treat the mama, 2 times something to the first. Leave the baby alone, x squared plus 4. Treat the baby function, 2x. All on the square of the thing below, x squared plus 4 squared squared, or to the 4th. All right, let's clean that numerator up here a little bit. 4x times x squared plus 4 squared. Let's see, minus 2 times 2x. 4x times x squared plus 4 times, we still have this, and I can factor that 2 out, and I don't think it's going to matter. 2x squared minus 8, all on x squared plus 4 to the 4th. And now take a look what we have here. I've got an x plus 4 factor here, or x squared plus 4 factor here, and I've got an x squared plus 4 factor there, and I've got 4 of them here. I'm gonna reduce the top and bottom by x squared plus 4. And we get 4x times x squared plus 4 minus 4x times 2x squared minus 8 on x squared plus 4, but just to the third. I divided the top and the bottom by x squared plus 4. Okay, let's clean that numerator up a little bit here. Oh, hold on a second. I can factor an x out of these. Well, that's kind of nice. I can factor a 4x out of these if I want. Maybe I want to do that. So let's go equals 4x times, we've got x squared plus 4 minus 2x squared minus 8 all on x squared plus 4 cubed, or 4x times, we're getting to a payoff here. Let's see, I've got an x squared minus 2x squared, a 4 minus negative 8, that's 12. I'm going to put the 12 first. X squared minus 2x squared minus x squared, all on x squared plus 4 cubed. Wow. So we end up with 4x times 12 minus x squared on x squared plus 4 cubed. And we're going to ask ourselves, when is that 0 after we take a breath? Well, if x is 0, it would fit between negative 2 and 2. This numerator would be 0. And if I go, I'll do it here, 12 minus x squared, when is it equal to 0? That's when 12 equals x squared, or when x equals plus or minus square root of 12 plus or minus 2 square root of 3. That would be outside of 2. 2 square root of 3, negative 2 square root of 3. That is when the concavity is 0. It's not cupping at those instants. So it's a prospect to maybe be changing from cupping up to cupping down. Let's see what happens. Let's put a number between 0 and 1 in, or 0 and 2 square root of 3, like 1 in here. If I put 1 in here, this is clearly positive. This is also positive, positive, positive. If I put negative 1, something back in this zone, negative 1, the first term is negative, or the first factor is negative, but the second factor, 12 minus, this would still be positive. Negative times positive, negative. How about something to the right of 2 square root of 3, 10. 10 makes this positive. 10, however, 12 minus 100 would make this negative, positive times negative. And let's try something in the zone to the left, negative 10. Negative 10 makes this negative. Negative 10 makes this 12 minus negative 10 squared. That's still 12 minus 100. That's negative. Negative, negative. Positive. So we do, in fact, have inflection points at negative 2 square root of 3, 1, and 2 square root of 3. If we are concave up from negative infinity to negative 2 square root of 3, in union with concave up from 0 to, this was 0, 0 to 2 square root of 3, and concave down, negative 2 square root of 3 to 0, in union with 2 square root of 3 to infinity. Wow. A lot going on here. Let's see if we can interpret this graph. I'm going to rewrite the function right here. F of x equals negative 2x on x squared plus 4. I'm going to learn 3 things here from plotting points in. F of 0. Why f of 0? Because it's really easy. F of 0 gives me 0 on 4, 0. Got a point right there. And now I'm going to find a value that's to the right of where all of the interesting stuff's happening here, and 10 would be fine. By the time we get to 10, we're well beyond where any of our interesting calculus type points are at. So f of 10 in this original function would give me negative 20 on 104. And leads me to believe I put bigger values in, the denominator is going to get bigger and bigger, the numerator is going to get bigger, but not like the denominator. So I would say, kind of an oxymoron, this thing is like negative 0. Negative divided by positive negative, and it's going to get closer and closer and closer to 0. So as x gets big out to the right, we're getting sucked in to 0. And that's somewhat comforting because take a look. The slope should be positive, but the cupping should be down. We're getting sucked into that. All right. Interesting points occurring. 2 square root of 3, 2. So let's go. Here's 2. Here's 2 square root of 3 maybe. Here's negative 2. I might regret putting that down there. I'm going to hold off on that for right now. All right, let's go ahead. F of negative 10. F of negative 10 gives me positive 20 on 104. That's trying to be positive 0. It's getting sucked in this way. Negative 2 square root of 3. So those are those are a number of things that I learned right there. What else do I know? I have a minimum at 2. The graph gets down as low as it's going to get at 2. At 2, it's cupping up. But the cupping changes at 2 square root of 3. Should appear to be cupping down and then cupping up after that. I pass through here. At negative 2, we've got a maximum. And at negative 2, it's cupping down. Cupping changes at 0. Cupping changes at negative 2 square root of 3. So cupping down to here, and then should appear to start cupping up. It's not really an angle. I'm just kind of maybe overemphasizing that a little bit. And there we have it in 12 minutes and 15 seconds. Challenging one. We got a lot of algebra going on in that second step, but you'll get some practice. Let me know what we can do to help.